Today on Coding 1, let's play some games, let's play some music, plus discussing object-oriented programming and function returns.
Netcasts you love.
From people you trust. This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
Welcome to Coding 101. It's the Twitch show that gives you the knowledge to live in the wonderful world of the Code Monkey. I'm Father Robert Ballisaire.
And I'm Shannon Morris, and for the next 30 minutes or so, we are going to get you coded up on all the code that you ever need to know.
That's right. Now, we've been talking a little bit about functions this past week, and I know it's been causing a little bit of angst in our community.
It's a little confusing.
It's a little confusing. I know, it's a high-level topic, and so we thought that it would be a good time for us to maybe do a quick rewind and bring you up to speed on what we expect coming into this lesson.
Exactly. So why don't we go ahead and hit it up with doing a really quick review of Lou's
Let's do that.
Lou's code from last week, and I'll also show you what I came up with as well, because I came up with some pretty cool stuff.
I've heard, yes.
So let's take a look at my computer, and I will show you Lou's code from last week and just give you a general overview of what he did. So he has a nice little while loop here, and then he goes into this function. Ta-da! So up here, he's basically saying, okay, if you click A, and I'll go into why that number 65 is there, or if you click B, you're going to choose this one. Click C, selection number 67, and then if you click Q, escape, or enter, you're going to hit 27.
Now, a quick note about this, because this was actually brought up in our Google Plus community. People were wondering, well, where did he get the numbers from?
Exactly.
Please just go ahead and jump onto Bing, jump onto Google, and look for C# and key press assignments. And it will actually give you what numbers are associated with which keys.
I actually did find a table for that over at the Google Plus community. Somebody linked over to that. So I'll show you in just a few moments of where you can actually find that. Now, going on with Lou's code, he also included a whole bunch of, generally a menu that you can choose from. Request a word, convert to binary, or just say hello, and then Q to quit. Each of these just goes into basically a string. So the first one is, what word do you want to repeat? You want to repeat monkeys. How many times do you want to repeat monkeys? Say 9 times, and then it prints it out 9 times for you. The second one he did was converting an integer to a binary. So you enter a whole number that you want to include, and then it goes into converting that integer into a binary down here. So it changes that right there. And as we scroll down, we see the third option, which is just saying hello. So it takes your name and it says hello to you. So let's go ahead and hit start. So I'll click on start and run it. So it just gives me the menu. I'll say, let's choose A. What word do you want to repeat? Monkey. How many times? 7 times.
Monkey.
B is converting to a binary. So I'm going to convert, let's do 56. So it converts that, a whole bunch of zeros. Wow, that's a lot of zeros. And then C is just saying, hi, Shannon, and I'll hit Q to quit. So very, very simple, and it basically took everything that we have learned up to this point and included all of those as different menu options.
Right.
So with my example, I decided to make a little game out of it. So I'm going to go up here to Open Project. I'm going to choose my project, my Snubs example, console number 1. Let's choose episode 6, Snubs example. Okay, so if you take a look at this one, it kind of starts off the same way as Lou's example. So I have this while loop up here. If you choose A, number 65, if you choose this one, it says magic. That's the name of that function.
Right, so you're just calling a function called runaway, a function called magic, and a function called sword.
Exactly, and then Q to quit. Down here, we have a whole bunch of different write lines for the menu. Run away, use a magic spell to stun him, stick him with the pointy end of my sword, because I watch way too much Game of Thrones. And then we have all of the different string options for you. So the first one is, the dragon chases you, fries you to a crisp. Oh, maybe I shouldn't give all these away.
Oh, well,
so
now
let's
we
play the game.
it.
Let's play the game, shall we? Oh, wait. All right, do you want to play a game? So you walk into a forest looking for trouble. What do you do when you run into a dragon? So I'll say, I'm going to do A, I'm going to run away. So in red, it tells you the dragon chases you and fries you to a crisp. Game over. So let's try again. So I'm going to choose, this time I'll choose stick him with the pointy end of my sword. So you use the sword on the dragon's weak point and destroy the beast. Congrats, you won. Do you want to play again?
Yes, I do.
Okay, so let's choose B this time. I'm going to use a magic spell to stun him. So what kind of magic spell do you use?
Oh, Avada Kedavra.
Avada Kedavra.
I can't remember. Sorry, Harry Potter fans. Yatta!
Magic spell Avada Kedavra destroys the dragon instantly. You won! Yay!
Now,
and then we can choose.
I love this because, I mean, this may be a little too old school for you, but I definitely grew up with MUDs, right? The dungeon adventures, text-based.
That's why I like doing
this. I love it. And you know, now you did a very simple one.
It's very, very simple. I could do much, much more advanced and have, like, if you choose magic, then you get a whole bunch of other options. So what kind of magic would you prefer? Fire, water, or air? And then if you choose air, something else happens, or you run away and fly off into the wilderness. So I could just definitely go much deeper with it, but I chose to keep it very simple for time, and because, well, I didn't feel like that much time.
You get to the end of the program, you go, okay, I'm kind of done with this. No, but what I like about this is your code demonstrates a few things that are very important about functions, and that is you want to be able to call these things whenever. If you were doing a full-blown text adventure, you don't want to have to put a bunch of if-else statements always at every point, spelling out every possible situation and every possible outcome. This way you could say, okay, here's outcome 1, outcome 2, outcome 1,000, and I just call it when I need it.
Yeah, exactly.
I love that. That's really, really good.
Super, super fun. Now, we were speaking about the character code, the different character codes that you can use in Visual Basic for Windows. I found the whole table of all the different keys that you can use and what their value are. So you have all sorts of different ones and descriptions on this link. This is over at msdn.microsoft.com. We'll put this link in the show notes for everybody that needs to use this, but this will give you a general overview of all the different ones and a nice little description of each one. Also, I did want to mention, whenever you do use this, it doesn't matter if you use lowercase or uppercase, because either way your output is going to be the same.
Correct.
Yay!
Yatta.
Now, we had a whole bunch of really fun
I love this part of the show now. I mean, anytime we get to see what people have done with some of the code that they've gotten from the show, please, more of that.
I totally agree. So we got quite a few on Google+. I'm just going to pull these up real quick, and of course you can find our Google+ community over at gplus.to/twitcoding101. This first one comes from Benjamin. He sent in 3 different ones. He just sent us the code, so I went ahead and compiled each one. This first one is very simple. It's basically just asking you to type in a 3-letter airport code, and then it gives you the actual name of that airport. So he only has a few ones available for this example, so I'll type in FRA, not FRA, I'm dumb, FRA, and it's Frankfurt. Would you like to go on? You can choose yes or no. So I'll choose no, and it closes it. Very simple, very
basic program. You come in, it asks you what data you need interpreted, it gives you the output, and then it asks you if you want to quit.
Yeah, it's great. It's very simple. I liked it a lot. The second one asks, how many numbers do you want to sort? So I'll say, I'm going to sort 6 of them. Number 1 is going to be 3, number 2, 65, 44, 78, 65, number 5 will be 12, and number 6 will be 9. So it takes those numbers and it sorts them from low to high.
And that's actually way more useful than it might look, because that's a basic sort function. It uses a series of conditions to tell whether or not is this number higher, is this number lower, is this where should it go in the order. That's actually key. That is a piece of programming that you will use time and time again.
And it's a very, very simple script, as you can tell when I was scrolling through it as well. So very easy to write, and I really enjoyed that one. Now his third one was awesome. I love this one. So let me just turn up my speakers real quick.
Oh no.
Okay, so if we take a look at this, he called it stopwatch. And if I scroll down, you see it says Super Mario right here. That's kind of weird.
That's a strange
duration of the song. And then over here, we have a whole bunch of beeps.
That's a lot of beep and
strange,
beeps.
right? Okay, so let's click start.
Now, if you haven't noticed, that is Super Mario's theme song entirely in console beeps.
That's so cool.
It is cool. Now, let this run. I will say, and I said this in the pre-show, when I was teaching, this would be the first thing I would tell my students they can't do. I didn't want console beeping just because they would always overuse it. But
it's annoying.
it gets annoying. It's fun now, but
so now it tells you the duration of the song was 26.98, which he had written that into the code, as we saw. So cool. I had no clue that you could use C# to make things come out of your speakers.
Oh, absolutely.
But it makes sense.
And again, this is one of those
Brian.
things. Now, the console command was one of the very first that we covered. In fact, it was the first command that we ever covered on the show. It is incredibly powerful. If you're in the IDE, if you're playing around with that integrated developer environment, go ahead and type console dot, and then it will give you a menu of all the different things that console command can do. The wonderful thing about that is you can then experiment. Go ahead and play around with some of the different options, some of the different features and functions of console, and see if you can maybe make it do something you were not expecting.
I love it. That is so cool. So much fun. All right, and of course, I have to share square
Iguana. Now, obviously, you are not just a novice at this, but your stuff is awesome. So yeah, let's take a look.
It's so cool. So this is his episode 4 example, or episode 3, excuse me. He said he couldn't find anything really interesting to do with just 4 loops. So he didn't already do in his last example. So here's a text to Morse code translator. Now, if you actually use the GitHub code that he includes with this comment, he says if you comment out, or I basically comment in the information, you can actually hear the Morse code come out of your speakers as well. So we got 2 examples about using your speakers with your console commands. Yay.
Yatta.
So awesome.
Square Iguana, you are awesome.
He showed a couple of other ones. I'll just run through these real quick. Episode 4 example basically takes this. I was originally going to move a character around, but creating the code led me to a bug in my code. That was interesting. The character led a trail behind him, so I thought this is something that I can do a little bit different. This is how simple the Paint application got started. So this basically tells your mouse movements to create a little painted snake on your computer screen. Isn't that cute?
Actually, very easily this can be turned into that like the snake game that everyone had on their phones back in the 90s and 2000s. It looks like a simple piece of code, but honestly, you could take simple pieces of code and modify them to do incredible things. That's what we're all about.
I love it.
Yeah.
And of course, this third one is from last week's episode, and this was about menus. So we did our own menus.
Now that's a menu.
A, B, or C. He created a really nice menu version, more of a GUI option, where you can select with your keyboard or your mouse, not a series of commands. So he decided to make a real menu. He didn't have the time or energy to create something for more complete, but he did create a page for each menu item, even if just a simple message. Very, very cool. Thank you, Square Iguana.
Square Iguana,
are really awesome.
You rule, and we will always play your stuff.
Well.
Yes, great examples, and again, please make sure you give us your examples. Either put them into the G+ page with the output, or give us your code. And you know what? If you give us your code, we'll add it to the Coding 101 Git so that people can play with it. Again, this is one of the things that I do all the time. I don't know about you, Shannon.
Yeah, I'm getting really excited about it.
Right.
It's so fun.
You take code that works and you go, oh, that's great. I wonder what happens if I do this. Let's add another loop. Let's put another console command.
Yeah.
And that's how you learn.
So how about let's move on?
Yeah, I think so. Now we're going to move on by moving back.
I think we should do a little bit more review about functions because I was a little bit confused.
People kind of freaked out. People freaked out. And it's okay. It's okay to freak out. It's because functions are so important, no matter what language that you're using, it begs a little extra time. But before we get to functions, I want to talk a little bit about something else that a lot of people were demanding we talk about in episode 1. It just didn't make sense. Now it does. That is object-oriented programming. Have you heard about this, Snubs?
I think so. I heard some people mention it in the Google Plus community, but I'm still curious what makes object-oriented programming different from any other programming.
Right. So the programming that you may be used to, let's say you started with BASIC. Okay, let's go way, way back. That's more structured programming. And in structured programming, the data is separate than the code. So what you do is you write the code, and then you run the data through the code, and you get output.
Oh,
okay. And it works. Structured program is actually very simple to pick up because in writing the instructions, it's easy for me to picture what it's going to do. But it's not all that flexible. And one of the other things about structured code is it gets us back into that nightmare of having to rewrite the same section of code over and over and over again, right? Because you're going straight down through it.
I don't understand why anybody would want to do that when you have the option to do it this way.
Right, right. Which is, the differentiation between structured programming and object-oriented programming, it's actually not that big. It is, as you get into the more modern languages, even the ones that aren't technically object-oriented languages have a lot of object-oriented language concepts into them. The basic concept is this. Rather than having my code and then have my data, I write it so that my code and my data are integrated into a single, what's called an object, object-oriented programming.
Oh, okay.
Right. So let me give you an example. Let's say I'm writing something for traffic management. Right? In structured programming, I would write this crazy, crazy long piece of code that could account for all the different variables that might possibly run through a traffic system. And then I would run data through it to see what kind of output I got. Right? Easy if it's a short program, but if that's long, I mean, forget that.
It would get confusing.
Incredibly confusing. In an object-oriented programming language, what I would do is I would break it down, just like we were always talking about from episode 1, breaking things down into their component parts, into the puzzles that could be solved easily by a computer. So rather than saying I've got one long program that runs the traffic lights, I say I have one object that turns lights green. I have one object that turns lights red. I have one object that looks at the cameras to see how the traffic is moving. That's the world of the object-oriented programming. It looks at code and at data as one thing. Rather than separating it, it says, here's a chunk of the world, I'm going to pull it out, and this is how I deal with it.
Oh, wow. Okay. Yeah, that makes sense.
Easiest way I can explain it. And that's why even languages that aren't technically object-oriented languages, they have a lot of object-oriented components, because if you're breaking down the puzzle into those pieces that the computer can understand, you're essentially treating it like an object-oriented language.
Okay.
All right?
Okay.
Does that make sense?
It makes sense.
Good, good. All right, now let's break this down a little bit. What I'd like to do is, if you could go ahead and bring up our GitHub and go ahead and bring up episode 5 code, we're going to look at some of the topics that we touched on last week in order to do a revamp of functions. Now, going to the Blackboard, this is the exact same Blackboard we had from last week. We know that the basic structure of a function is this: visibility, return type, name, parameter. Now again, to explain that, visibility is just whether or not the function can be seen by whatever. You can set it public, you can set it private, there's a couple of other different visibility parts. Don't get confused by that, because the main action is going to happen after it. That's this: the return type, the name, and the parameters. These are probably the most important things you'll deal with right now, before you get into super crazy complicated programs. The reason for that is the return type is something we're going to be playing with today. We've been using functions just to execute static code. Right? So we've been using them like procedures. In other words, when I call the function, go do something. But that's not the most cool thing that a function can do. What a function can do is actually return something to us. So we could give it some data, it could work on that data and then return an answer to us.
Oh, that's cool. So we could make it do math, or we could make it relay a really broad example for just typing a few keys.
Or we could say return a string, something that we wanted to print. You know, basically anything that's a variable, anything that you've played with already when we were talking about variables, you can make a function return.
Cool.
The way that we do that is this: we have to tell the compiler what kind of data is it going to be returning back. Is it going to give me an integer? Is it going to give me a string? Is it going to give me a floating point? All those different types work here. Now the name is just, it's like a variable. It's just the name of the function.
And you can name it whatever you want.
I can name it anything I want. Just remember that because it's object-oriented programming and because it's a function, we like to call functions that are descriptive. Right? I don't want to call this function X, because function X could mean anything. I want to say light turn red.
Well, a good example was when I did my little game on here, my text-based adventure game. I named my different functions sword, magic, and runaway, just one word.
Exactly, right.
And it was descriptive enough that I knew exactly what it was going to call back.
And the reason why we do that, and we've talked about this before, is if you said function 1, function 2, function 3, you would understand that because you're sitting in front of your screen for 2 hours and you get your code.
But if somebody else had to come in and look at your code, they would just be like, what does this mean? And then they would have to Google function 1 or try to figure out what it was.
And that illustrates one of the or three of the things that make object-oriented programming better.
Right.
The first is that it's easier to understand, because if you've got functions that are actually called by what they do, it's easier for someone else to pick up, or even for you to pick up 6 months down the road and say, oh yeah, okay, I know what it does because the function's named.
Yeah.
Also, it's easier to maintain. In other words, if I need to fix it, if I have to go back in the code, I don't have to remember, oh, it was function 5532 that did this, or no, I look for, there's something wrong with the menu. Well, let's go to the menu function. Boom, done.
Perfect.
Also easier to upgrade. Because I've encapsulated everything within those functions, it's easy to pull that function out, put it someplace else, or replace it with a better version.
Oh, that's so true. I didn't even think about that, but yeah, you're right.
Yeah, that's, again, one of those things that we like about object-oriented programming.
Cool.
Now let's go back to this. Okay, so we know that we've got our function declared with visibility, return type. Let's say it's an integer, right? It's going to return me a whole number. And then the name is going to be
date of birth.
This, an answer.
Answer, sure.
Again, that's not a great name.
No.
I would never use that in an actual program, but we're going to do it here because the chalkboard is small. And then the parameter is the data that's going to go into the call. So remember what I said in object-oriented programming, we treat the data and the code as one object?
Yes.
Well, in order for me to have that, I have to have my code and I have to have my data. My parameter gives me the data.
Okay.
Okay. Now here was the example that we had. We have public, so it's a public function. Int, so it's going to return an integer. Answer, that's the name of the function. The function is called answer. And then int a and int b. So I know that it can receive 2 whole numbers. And then when I run it, my code inside says int c equals a plus b. So c is going to become the sum of anything I pass into the function.
Right.
So if integer a comes in and it's worth 3, and integer b comes in and it's worth 2, integer c is going to be worth a plus b, which is 5.
Ah, yeah, okay.
But now here's the trick. Return.
Return.
We didn't use this in any of the functions from last week, right? Return c. So what I'm now saying at the bottom of this function is take the value of c and return it. Return it as answer. So whatever piece of code called the function. So I called it.
I get it.
Yeah. So when it will come.
Awesome.
So let's say I set that answer x, y, and x was worth 3 and y was worth 2.
Yeah.
When I call it, this is going to come back and replace answer with 5.
Right. Yeah,
That's
I
it.
totally get
That's
it
all
now.
it is. Yeah.
Okay.
So that's what a function is when we're using the return.
That's so cool. All right, so we have a public integer named answer. It's going to look at both of those integers, a and b, whatever that input ends up being. And then it runs the code that says integer c is going to equal those 2 inputted numbers, a and b, and it's going to return to you that answer, which is c.
Right. Now,
That's awesome.
I want to extend an olive branch to the more experienced code monkeys, because there's a lot of people out there who they really got upset. They're like, wait a minute, C# doesn't have functions. That is technically true, because C# doesn't have any standalone functions. Every function inside of C# is attached to a class, which is another programming thing that we're not going to talk about right now, which technically makes it a method. But it works the exact same. And the reason why we're calling it a function is because function is the universal term. That works across all programming languages. So if you are brand new at coding and someone comes up to you and says, oh, you do realize that you're not actually making functions, you're making methods, just smile and say, yes, yes, I know, and continue writing your function. Don't get confused by the terminology.
Okay. Well, yeah, I see why you're calling it a function then.
Right, right.
Just so I don't get confused.
Well, yeah, because we're going to be talking about a lot of different programming languages on Coding 101.
Right.
And function is the universal term.
Okay.
Right? It might be called a procedure, it might be called a method, but it works. If it works like a function, if you code it like a function, if it returns a value like a function, it's a function.
Right. Got it.
All right.
All right.
Now, isn't this normally the time of the show where we invite someone, like a code warrior, to come on?
I think it is.
Yeah.
I think it is.
Yeah. You know what I hear? I hear Lou.
You hear a call? Oh, I hear a call.
Actually, I hear the beach. Lou, where are you?
Hey guys, I'm in San Diego this week. It's actually raining here, so I brought the rain with me.
Ladies and gentlemen, Mr. Lou Maresca, he is our code warrior. He's an employee of Microsoft. He's been coding for them for an awfully long time. Also a regular here on the TWiT TV network. You've seen him on This Week in Enterprise Tech. You've seen him on Padre's Corner. You've seen him on Tech News Tonight. And yes, you've seen him on Coding 101. Now, Lou, we wanted to go back into functions because I have to admit, I don't know about you, but I got a little bit of panic, right? Some people were panicking, going, "Oh, what?"
Well, yeah. When I started writing my own code, I was like, "What am I doing?"
Yeah. And so we're hoping maybe you could show off some of the nuances with functions, specifically this return thing.
You bet. So first thing I want to show is basically a basic function that returns some type of variable that's of some type. So in this case, it's going to be an integer, which is a number of some type, 32-bit integer. And what we're going to do is we're going to have this function specifically take a couple numbers. One be how far we're going to go in miles and how many minutes we have left to get there.
Right.
And so what this function does is it's going to return a number to tell you basically what speed you have to go in order to get there in time. And so if we notice the functions, what we call the function schema is it takes a number decimal, which is the distance in miles, and again, another decimal, which has a decimal point in it, and how many minutes you got left. And so those are the two variables it takes. And then it has this return type over here. So normally we showed most of our functions had a void, which basically said that it returned nothing.
Right.
In this case, we're going to be returning an integer. Oh. And the reason why it says it's static, it just means that that function's always there available for everybody.
Right.
And I'm sure we'll get into that later on once you get into object-oriented programming. But for right now, just know that just means it's there for everybody to use. And the int just basically means it's a number returning. So in here, real quick, I set a variable. Say basically, this is my return variable. If you notice down here, I have a return statement saying this is the number I'm returning. And if I actually remove this return statement, if I comment it out real quick, you'll notice that it gets angry at me. It says not all code paths have any return value, and the return bit's because I have a return value here. Right,
it's because you said int, so you're telling it that the function is going to be returning something, and then within the code, there's nothing that actually returns a value.
That's right. That's right. The IDE is going to get angry at me and saying, "What's going on? Why aren't you returning anything?" So I'm going to put this back, and then that should go away. And now I'm actually returning the variable that I created up here. And I can get rid of all of this code if I really wanted to. If I comment this all out, it'd just be returning required speed. And that would meet the requirements of that function because it's returning a number.
Which would be 0.
That's right. So in this case, I'm just going to do a real quick calculation. Obviously, amount of hours based off the minutes. And then I'm going to calculate the speed by rounding down the number of miles, distance miles divided by how many hours. And that should give me miles per hour. And then that will return back. And so if I go back up to how I'm calling this function, again, this is just some console stuff, but it just says how many minutes into your appointment. And again, the way I'm calling the function is by, if you go down here, once I get the minutes left and the distance in miles from the console, this is the same console stuff we've done before, I then call the function right here. And you notice I'm passing in both the distance in miles and the minutes left into that function. And then you notice this little equal guy over here. That's basically saying, the return type, or that number that I'm returning, save it in this other variable called speed in miles per hour.
Right.
So once we have that, we are just going to display that to the user and say, okay, this is how fast you actually have to go in order to get there in time. And then I also have another function that
actually, Lou, let's step back just a second because the integer line. So starting with integer speed in MPH.
Yep.
Okay, so this is an interesting line here because he's declaring a variable, an integer called speed in MPH, and it's equal to, then he calls the function. He's calling the function called required speed in MPH, and he's passing it two numbers as parameters, distance in miles and minutes left. So again, this is one of those things that...
That's just like what you had on the board.
It's exactly what we had on the board, but he's doing it all in one line.
That's cool.
I'm sorry, Lou, go ahead.
No problem. So exactly what you said. So once we pass it in, it does its all magic that's underneath the hood here, and then it returns the number back, and we stored it in the speed in miles. And then all we do right now, then we basically display it to the user, and we say, hey, this is the speed you have to go in order to get there in time. And then we also have a little function for people who are using metric. We have one that converts miles per hour to kilometers per hour, and that basically is another function. It's a very, very simple function, and all it's doing is taking the speed, which is a number, in miles per hour, and again, it's doing a little math on it, converting that to kilometers per hour, and then it's returning. We said we're going to return an integer or number type, and we need to return that, so we're basically returning the number. And then again, back up here, we store that in another variable. So again, we do the equal sign, say the variable equals the return of that function, and then we write that to the console. So we run this, basically it says how many minutes. I have 30 minutes to get there, and I have about 45 miles to go. It's basically saying you need to go 90 miles an hour to get there.
You need to
Good
haul.
luck with that.
Go.
Oh, that's
So
cool.
so basically that's pretty much it. And then the nice thing about it is I don't have to put all this special code with inline here, so it gets a little bit kind of cluttered here over time. So that's kind of what functions are all about.
Right.
Is they're about kind of reducing the size of your program and making little functional pieces, things that make sense, into small chunks.
They're keeping your code clean so that if anybody else has to look at your code, they will understand what's going on.
That's right.
Right.
That's right.
Now, people who are getting a bit more advanced in code, what they're going to find is, if they're doing it right, the actual main section of the code, right, the main function, is going to be really, really short. There shouldn't be a whole lot there. It should be calling other functions that are actually doing all the work. And what you see in Lou's example, which is I love, he's got functions that are calling other functions. And that's what we want to do, because then it leverages all the code that you've written before. Rather than writing something 15, 16, 17, 100,000 times, you write it once and then you call it as many times as you need it.
Now, I do have a question for you, Lou. Since you were pulling 2 decimals, and then the integer was the one that got outputted, can you still have a decimal come out instead of a full number?
Yeah, you could do that. The reason why I just had a full number was just so that it was kind of rounding up. Nobody really knows how to go. I guess people do know how to go 10.5 miles, but
I totally know how to do that.
Yeah, it makes sense. Go faster, you know. But in this sense, yeah, you could basically, if I really wanted to, I could change this to a decimal. Again, change this to a decimal, and I don't even have to convert this then to an integer or round it in that case. I could just leave the math here to basically say divide by that, and now that's it, and then I can return the decimal up here. So it makes this code a little simpler. Yep.
Well, that's the first time we've seen decimals on the show. Yay!
Woohoo! Yatta! Yeah. Now, Lou, I got to ask this. So someone who is looking at your code afterwards, because we're going to make your code available on the GitHub, just go into the show notes and you'll be able to pull up everything, actually all the examples from today's show. But someone who's looking at it, and we're going to ask them to play with it, because that's what we always do, right?
Absolutely.
Get in the code, play with a couple of things. What would be the thing that you think they need to play with the most? What's the thing that they should break, the thing that they should try to rename? What's the thing that they should try to practice so that their proficiency with functions will grow?
I think the best thing to do is just try things out. You know, just basically go in and remove some things. Let the IDE kind of tell you what's going wrong, and then try yourself at actually doing some calculations and adding some more functionality in there, and then maybe even add some additional functions. So in my case, I returned kilometers per hour. Maybe go in and ask the user for kilometers per hour and convert it to miles per hour. Maybe create your own function to do that. Add some more functionality to the application, try it out, and see how those functions then work for you.
Yeah. Now, T. Joe in the chat room actually has I remember this. I love this. When I was still working code, he said one old school rule of thumb was, in general, that a function should stay within one screen load. So you shouldn't have to scroll up or down. And I was always told if it needs to go more, it means you need to break out functions.
Well, gosh, I guess we're lucky that our resolutions are getting better here.
But I got to ask, Lou, I mean, obviously, programs are a lot more complicated now than when I was still coding. Is that still something that you try to do? And the reason for it was because if you could have it all in one screen, it means that it was simple enough for someone to take an at-a-glance look and say, I know exactly what that function does.
Sure, I think functions. It's a good rule to follow. Like Snubs said, sometimes the resolution is so big you get a lot in line. But it's a good rule to follow. The only problem is over time, the more functions you have, sometimes you do want to kind of have the same function do a bunch of things, and that's only because you don't want to have to piecemeal everything out into little smaller things that you won't ever use again. A lot of people, when we get into object-oriented programming, we'll talk a lot about private things versus public things. And a lot of private functionality can sometimes get really complex because people try to break it out into lots of little tiny small things. But I think it is a good rule to follow that if you have small, this much code to fit on the screen, it makes sense to have that much functionality within there. And then, as you go on, you can kind of add more functions and so on. But you don't want to get too crazy with it, at least.
Well, let's hear a code confession. Lou, what's the longest function you've ever written from Microsoft?
I think it was I'd say about 400 lines, maybe 450 lines. It's that's pretty long.
Definitely does not fit in one screen.
Yeah.
But again, you're right. I mean, it is a good rule of thumbs. As T. Joe mentions in the chat room, it is a good rule of thumbs to try to break it down. But you get to the point at which, if you know you're never going to use that piece of code for anything ever again, and you're only busting it out into its own function in order to meet that rule of thumbs, that's when you break the rule of thumbs.
Okay.
Yeah. Well, Lou, thank you so very much. I mean, hopefully, this is now easier for people to understand, and they're going to go forth.
It's easier for me.
And function, exactly. That's what we want. Now, next week, let's get the folks excited here. Next week, we had a little chit-chat here. We want to start getting into some graphics and animation, right?
Absolutely.
Definitely,
I'm super excited about that.
Yeah. So
maybe some Windows Forms programming.
Yes. So we're going to be stepping out of the console a little bit, and Lou's going to show us some interesting doodads with what else you could do with C#. But until then, Lou, thank you so very much for joining us. You want to tell the folks at home where they can find you?
Definitely, Lou. I'm at on Twitter, and then of course next week I'll be in Florida. I'm sorry, not Florida, Atlanta for Convergence 2014. So come out if you guys are in the area. Come out, check out my session there.
Yeah, everyone should say hi to Lou MM. He really isn't. He's a nice guy.
I'll come out there just to say hi to you.
Yeah.
All right, sounds good.
Yeah. Now, until then, we've got a couple of tools to help people who may be still freaking out about functions. Shannon, you want to tell them all about our show notes?
Absolutely. So we are over at twit.tv/code. That's where you can find all of our show notes and a link to our GitHub, which is where we post all of the code from Lou as well as myself.
That's right. And don't forget to subscribe to us on iTunes. If you're an iCoder, we want you to spread the word about Coding 101 wide and far. And you can help us tell the world about the rise of the Code Monkey. Go ahead and jump into iTunes and make sure to subscribe to help us stay up on that leaderboard.
And of course, if you're not on iTunes, you can also find us on YouTube. We're at youtube.com/twitcoding101.
Exactly.
Please subscribe.
Yeah, please do. Also, we've started a Google Plus community. It's still fledgling. There's about 500 users or so, but we're hoping to get it much more active and much larger. The nice thing about this is we've got people in this community who have been coding for years and years and years.
Yes.
And they can help you. If you get stuck, if you get frustrated, if you're like, I don't know what to do with these, jump into that community and they'll help you out. Just go to, what is it? It's
gplus.to/twitcoding101. And I should mention, Joe in there actually asked me in episode 4 when I saw a bunch of windows pop up beneath my code. I said, what is that? Turns out it's a debugger running in the background.
Boom, exactly.
Bam. Yeah.
So there's so many of the questions that you might have can be answered by those guys in just a moment's notice. Also, if you don't like jumping into Google+, why not catch up with us on our other social networky type
social
thingies?
networks.
Yeah, you can find me on Twitter. Yeah, so I do the tweeting thing.
Twitters.
The Twitters, yeah. You find me at twitter.com/PadreSJ. That's at PadreSJ.
And I'm at Snubs. Super easy.
Yeah. Also, did you know that we do the show live?
We do.
Yeah, we're actually here.
Oh.
It's weird, right? Yeah, every Thursday at 1:30 p.m. Pacific time, you can find us at live.twit.tv/Snubs is hiding under the table. Also, as long as you're going to watch us live, why not join us in the chat room at irc.twit.tv? There you'll be able to talk to some of the very same people who make our G+ community so awesome.
It's true.
It is true. Until next time, I'm Father Robert Balaser.
I'm Shannon Morse. End of line.